Hello and good day, Doctor. My name is Mohamad Eiman bin Zanuri, and today I would like to share my findings about my final year project, Industrial Thin Plating Process Optimization using Hull Cell Test Kit, with supervision of Dr. Zaimi bin Zainal Abidin. This video is presented to all of the panels, PM Dr. Jariah binti Mohamad Juoi, Mr. Khairul Fadzli bin Samat, and Madam Adibah Haneem binti Mohamad. For the outline of my presentations, there is 6 parts prepared, which is number 1, introduction, number 2, problem statement, number 3, objective and scope, number 4, the findings of the literature review, number 5, methodology carried out to achieve the objective, and lastly, conclusion. I will brief a short introduction about my project. Thin electroplating is one of the most common plating techniques used to apply protection coating on metal substrates. In subitexon rubberhide, thin electroplating is done on copper substrate for medium power flexible connector application. The plating parameters such as current density and plating bus composition are fixed as technical datasheets by the supplier. Dr. R.O. Hull created the Hull cell, which is a tank for plating testing. By adjusting plating conditions, it is also easy to see the link between current density and state of deposition. By varying the distance between anode and cathode, deposited film is a wide range of current density may be observed on a single test piece. The problem statement for this project is mainly for industrial thin plating process. The thin plating process is the most efficient way to protect the substrate against environmental damage and also improve the finishing of products. In this study, the current density supply are not the same as the current applied to the copper substrate due to resistance in wirings, plating jigs, and plating solution. Furthermore, the chemical mixed up by the company personnel is very crude, using a very large volume of chemicals for 2000 liter baths. The distance of anode to the substrate is also very crucial, since the electric field has a significant effect on the thin plating thickness and its morphology. Hence, this study is conducted to understand the effect of parameters and compositions to the thin plating surface morphology using Hull cell test kit. The objectives of this study are 1. To study the relation of distance between anode and cathode and its surface morphology. 2nd. To compare the actual industrial thin plating and lab plating surface quality. And 3rd. To study the relation of current density on the thin plating surface morphology. Let's move to literature review. Fred DiBallo, 2018, said that before to electroplating the copper, the top titanium layer is wet etched in a solution such as 2% hydrofluoric and 0.5% nitric solution with etching rate 500 to 200 A per minute depending upon oxidation of the titanium. Plating offers a manifold of advantages such as accuracy in control, low energy requirement, flexibility, high production rate, economy in scaling, even coating, waste reduction, and the capability to coat more complex topology and geometry. Juoi and Mohamad, 2014. Thin electrodeposition is also gaining ground due to its ability to perform in core areas of corrosion prevention, fabrication of electronics, and plating of equipment, and cooking utensils. FC Walsh and Low, 2016. A Hull cell test kit is a testing tool, all a miniature electroplating cell in which an electroplating solution is evaluated across the range of operating conditions. Also useful in demonstrating the capabilities of a plating bus solution. TW Jelini, 2012. In semiconductor industry, thin plating is applied to component leads to make the solderable to print circuit board PCB. There are few types of plating machines, example reel to reel, strip to strip, barrel, and rack plating. AC10, 2018. Palisrivanas 2016 show us modified hull cell geometry. The current density gradient is established along the length of the angle working electrode due to the geometry of the electrodes in the modified hull cell, where it is increased from LCD end to HCD end of the working electrode. This allows researchers to study the effect of wide range of current densities on the quality of the coating in a single experiment. For the first part of methodology, I will explain about the progress flowchart of the assessment. The procedure of the onward is started with project selection with my supervisor, Dr. Zaimi bin Zainal Abidin. After that, the project problem statement, objective, and scope are defined, and the research for literature review are made through reading journals, articles, website, books, and case study example, and also thesis. Methodology are designed based on the problem statement and objective, and also need to pass the verification of the literature review. The findings from literature review are then being studied and analyzed. If the findings are being verified, then the data are discussed with the industrial supervisor and meeting with the company is conducted. A test run are made to ensure the quality of standard product in the company are achieved. The process of electroplating processes are as below. Firstly, start by cleaning processes, which because the surface must be free of contaminants for bonding to take place. Second, rinse and dry if needed. Third, acid cleaning and etching. Sandblasting with aluminium oxide will roughen up the surface so that the plating metal etches better. 4. Rinsing again if needed to execute the acid. 5th, conversion coating or plating baths. 6. Water rinsing for 1 minute. 7. Chemical rinsing to make parts more rust resistant. And 8. Rinse in hot water for finishings. Morphology is observed using scanning electron microscope (SEM). The thickness is measured using ultrasonic measurement method and optical microscope. The STD-MD 3359 tape test is used to observe the thin coating HSDT. The STD-MD 3359 tape test is used to observe the thin coating HSDT. Microbeakers hardness tester is used to measure the thin coating hardness. The thin coating thickness is expected to have a thinning as the distance between the anode and cathode increase. The higher current density may produce a thicker coating with higher hardness compared to low current density. As for the conclusion, the project planning has been followed. We are expecting to obtain a comparison of the actual industrial tin plating and lab plating surface quality. There is also improvement of distance between anode and cathode and its surface morphology, result of the relation of current density on the tin plating surface morphology, and also all case study has been carried out to complete the objective.